Hello, my name is Javier Rodriguez. I am a Power BI data engineer at Prima Consulting UK. Today, I would like to show you what is a windowing function in SQL Server. Let's get started. Let's start by defining what is a window function. In SQL, a window function is a type of function which uses values from one or multiple rows to return a value for each row. These values can be the result of an aggregation, ranking, or offset. This construct with an aggregate function which returns a value for multiple rows. The difference between these two is in how you define the set of rows for the function to work with. With group functions, you use group queries to arrange the queried rows in groups, and then the group function are applied to each group. You get one result row per group, not per underlying row. With window function, you define the set of rows per function, and then return one result value per each underlying row and function. You define the set of rows for the function to work with using a clause called over. The window function has an over clause. Without this over clause, it's not a window function, it's an aggregate function. Window function also enable you to perform data analysis and computation. As I said before, there are three types of window function: aggregate, ranking, and offset functions. Let's start with aggregate function. Window aggregate functions are the same as the group aggregate function. For example, sum, count, average, mean, max, except the window aggregate function are applied to a window of rows defined by the over clause. As mentioned, you use over clause to define the window of rows for the function. The window is defined in respect to the current row. When using empty parentheses, the over clause represents the entire underlying query result set. For example, this expression sum val over represents the grand total of all rows in the underlying query. You can use window partition clause to restrict the window. Let's start with sum function. To clarify all these concepts, I am going to use AdventureWorks TW 2022 database and particularly fact internet sales table. Let me show you Management Studio. Okay. In here we have AdventureWorks TW 2022. This is this database is a data warehouse, so it has the fact and dim tables. In this case, fact internet sales contains the surrogate, the primary keys of the different dimensions. And the primary key of this fact internet sales table are conformed by sales order number and sales order line number. Let me show you how is this table is being created. Okay, contain product key, all the primary keys of the dimension tables. Here we have the transactional sales order number and the sales order line number. So all these line numbers conform one sales order. I would like to calculate the total sum by customer of the sales. I can calculate this the sum in two ways, using aggregate functions or windowing function. The first one, I'm going to use the aggregate function sum, and this sum mandatory I need to use group by, in this case by customer name. If I run this query, I will obtain the different customer names and the total sales by customer. In this case, Aaron Adams is 179.96. I'm going to do the same with a windowing function. First of all, I don't need to group by because I don't want windowing function is not mandatory. So it will be created by partition. In this case, the total sales by customer will be obtained by this line number 15. So we are summing the sales amount partitioned by customer key. In this case, Aaron Adams, the total value is correct, however, it's showing the underlying calculations. So for the row number 1, we have the same value, line order line number 1, 2, and 3 and 4. We have the same total sales. In this, we can use this partitioning without any partition. So in this case, we are going to sum the total sales amount of this window of this query. In this case, this number. The good thing of a windowing function, we can use this windowing function to make calculations. So we can divide the total sales by customer divided by total sales. Or we can calculate the percentage of sales per order. We can combine both. So the total percentage ordered by customer is calculated by two windowing functions. The total sales amount by customer key and sales order number divided by the sales amount of the customer key. So in this case, this order number represents 100% of the sales of the customers. In this case, Aaron Bryan, we have two orders, and the first order represents the 44% of the total sales of this customer. So this windowing function, the sum, give me an scalar and I can use to make calculations. This is the good thing of aggregate function and windowing function. I have here another calculation which represents the total sales amount of the total sales for every single customer. Customer sales over the total sales. So it's 0% because it's so the sales of this customer are £100 over 100,000 over 20 million, so the percentage is so low. This is the reason because it's 0%. Represent every single. Another benefit of window function is the ability to define order when applicable as part of a specification of the calculation without conflicting with relational aspect of the result set. That's it. Order is defined for the calculation and not confused with presentation ordering. The ordering specification for the window function is applicable, is different from the ordering specification for the presentation. If you don't include a presentation ordered by clause, there is no assurance that the result will be returned in a particular order. If you do decide to force certain presentation ordering, the resulting ordering can be different than ordering for the window function. Another important aspect of window function is framing. The idea is that you are defining ordering with the partition using window order clause, and then based on that order, you can combine a frame of rows between two limits. You define the delimiters by using window frame clause. The window frame clause requires a window order clause to be present because a set has no order, and without order, limiting rows between two delimiters would not have no meaning. In the window frame clause, you indicate the window frame rows or range, and the window frame extend the delimiters. With the rows window frame unit, you can indicate the delimiters once of the three options, unbounded preceding or following, meaning the beginning and the end of the partition respectively. Current row obviously presented the current row, and rows preceding or following n, meaning n rows before after of the current row respectively. As an example, this query calculates the cumulative sales by customer. Let me show you. Here we have framing. Okay, so for example, we have here the customer name, the order name, the order line number, the order date, and the sale of this order. And here we have the cumulative sales order by customer. So the first order is 399. The second is the addition of this 399 plus 2499, and so on. So for this customer and order number, we are aggregating cumulative. The good thing of the window function is you can see row by row how the calculation is being done. The logic for this cumulative sales order is similar to the previous one. Sum sales amount over partition by customer key ordered by sales number, which is mandatory, sales order line number, and sales amount, and the rows between unbounded preceding and the current row. So we are aggregating, we are summing sales amount until to the current row. So the total for arms is 170.96. So this strategy is very useful when we have to calculate cumulative sales orders, for example, when we need to calculate running total, for example, is very useful.